So, good morning again. So, in this session, we are going to talk about concave mirrors and convex mirrors. Okay. So, we are basically dealing with reflection from curved surfaces. Okay. So, when we talk about curved surfaces, there are certain terms that you need to understand, you need to know, because these terms will be used quite often. Okay. So, first I give you a very brief introduction regarding what a sphere is and what are its properties and how we cut out the mirrors from it. Okay. So, this is a sphere, right? So, as you know, every sphere would have a center. So, that center is C. Okay. And the sphere also has a radius. So, this is radius R. Okay. Now, note an important point that if I draw any line from the center onto the surface of the sphere, right? So, this is a ray of light that I have drawn from the center onto the surface. How would this ray come out of the sphere? Right? So, it's coming out that way. So, you call that as radially outward. What do we say? Radially outward. Now, what is the character of this radially outward line that we are having? Children, you are familiar with the term tangent. Okay? So, this is a tangent. So, what is a tangent? Tangent is any line that touches a single point over a given curved surface. The curved surface could be a sphere, it could be a parabola, it could be an ellipse, or it could be any hypothetical curve. Okay? So, now if you observe this ray that is coming out from the surface of the sphere through the center, it makes a 90-degree angle with that line, with the tangent, isn't it? So, therefore, any radius is always normal to the given surface. This is a very important thing that we have to realize when we talk about spherical surfaces, be it reflection, refraction, or anything otherwise. Okay? So, every ray that comes out through the center, throughout the surface, is always a normal. Okay? So, here we come across three important terms. One is center of curvature. What is center of curvature? Center of curvature is the center of that sphere of which the given mirror is a part. Right? Likewise, radius of curvature. What is radius of curvature? It is the radius of that sphere of which the given mirror is a part. Say for example, I have chipped out a part of this sphere. So what would I get? I would get something like this, isn't it? So this is what we would get, right? So this part we call it as the aperture. This is the aperture of the mirror. Likewise, the deepest point you call it as the pole, and this is the curvature. Clear? So this is curvature. Okay. Now, if on this curvature you have mirrored the outer surface, then we call this as the concave mirror. Okay. If in the same fashion, if I have a curvature like this and I am coating the inner part such that the outer part is the reflecting surface, then this I call it as the convex mirror. Clear to all? So these are the few basic things that we need to know, and once we have realized this, I'll just tell you one simple thing and then we will move on to our problem solving session. Okay? So say this is a concave mirror, right? and we will explore the beauty of plane geometry in this particular figure, and it's just a 1 minute job. See, this is the center of curvature, right? As I have told you, anything that comes through the center of curvature would always go normal. So if I throw a ray of light like this, then it would be reflected back in the same direction. Now assume that we have a ray that is parallel to, right, the line that joins the pole and center of curvature. This we call it as the principal axis. We call this as principal axis. Now, this ray of light has an angle of incidence I with the normal, so therefore it gets reflected back at the same angle I. Is it clear? Observe that these two sides would always be equal, and that this point of intersection PF is exactly half of PC. Okay, so that means PF is exactly half the radius of curvature. So therefore, this distance PF I call it as the focus. So focus for a concave mirror or a convex mirror or any mirror, that which is a part of the sphere is always half the radius. With this, you are acquainted with all basic nomenclature of mirrors. Then next we will do